Okay, welcome back. Pardon me. I just want to have you start off by looking at your homework from yesterday and or from over the weekend, I guess it was for some of you for Friday. Um, as you're looking at this set of homework, you can pause and start your video as needed and check out what you got right or wrong. Sorry about that. Anyway, as you're looking, if you got something wrong, fix it. This is your time to learn. So, problem 98. Half of 90 degrees was 45. Problem B, the 90 plus the 45 together made 135. And C, 90 divided by 3 is 30 degrees each. Problem 899 was a proportion problem, and I cut the one whole into thirds, and $7.50 was 2/3 of that original value. So if I do x is to 750 as 1 is to 2/3, that's one way to do the problem. And then you could cross multiply. 2/3 x equals 750. From here, you could do a big monster giant 1. Let's see if it'll let me do it. See the giant 1 right here? And then 750 divided by 2/3, which is the same as 750 times the reciprocal, 3/2. And you end up getting, let me pause my recording. Okay, going back to where I was. Sorry about that. I got interrupted with somebody who came into my room while I was videoing here. So if you take 750 times 3/2, you end up getting, it's horrible, 2250 divided by 2, which is $11.25. That's one way. Or you could have done this. If 2/3 is $7.50, then 1/3 is $3.75. Add those together to get one whole. You get $11.25. Problem 100. Again, I'm going to do that one with a percent picture. 100% with 60 miles per gallon, and 65% of that. So 30. I guess this was a 35% decrease. Would make 65% match up with X. That would be method 2. 35% of 60 of the original is 21. When you subtract that off 21, the new mile, it's 39 miles per gallon. But method 2 is to know that if you take away 35%, you're at 60%. So, or 65%. So 65% of 60 is this value, which is also 39.65 times 60. So anyway, 39 miles per gallon. Problem 101, I went back to drawing the diagram to compare which side was bigger. I first took these two negative x's from both sides. I removed the x from both sides. I removed this 0 pair and that 0 pair and had -3 compared to -2. So -3 is less than -2. The right side is bigger. Problem 102. I used the giant 1 method to figure out n was 96. In part B, I again used the giant 1 method to figure out n was 128. C, I had to figure out that 26 times 1.5 was 39. So if I use that giant 1, 20 times 1.5 is k. That makes k 30. And the same thing on D. I used 2.5 for my giant 1. And problem 103, probability of getting a black vehicle was 4 out of 20. So that would be a 1/5 probability. All right. Moving on to our new lesson. So this is actually the second day of the lesson we did yesterday. How many triangles can I make? And yesterday we figured out that if there are 6 different parts to a triangle, and so 6 measurable parts to any triangle, there are the 3 angles, and there are the 3 sides. If I give you any 2 of those pieces, it's not enough information to draw the same triangle. So two pieces of information. Like if I said, okay, build a triangle with an angle of 30 and an angle of 50, that wouldn't be enough, because then you would end up finding out that you could make the triangles bigger or smaller. They might be similar in shape, but they're definitely not the same triangle. And the goal was to make the same triangle. Well, today we're going to increase that to 3 parts. What happens if I give you 3 parts? Now, you might be able to predict what happens. I have a feeling it's going to work so we can draw the same triangle, but it doesn't always work. So that's what we're going to be looking at right now. So here we go. Yesterday, I had you looking at a video that used the GeoGebra tool, and we're going to use that same GeoGebra tool again today to create a triangle with sides 3, 4, and 6. I'd like you to do that. Pause your video. You're going to go to this tool, the same one we used yesterday, but I want you to make the 3, 4, 6 triangle and figure out if you have a different one by just adjusting these sides until it forms a triangle down here. I need you to also adjust those angles. Remember yesterday we could move the angles around until we get that triangle. So take your computer, pause for a moment, and please make a 3, 4, 6 centimeter triangle. All right. Hopefully you paused. I know some of you probably didn't. I'm going to make a 3, 4, 6. I'll make this one 3, and I'm going to make the red one 4. Now you might have done it differently, and I'm going to make the green one 6. Whoops, too far. What am I thinking? So that would mean I'd have to move this red piece to where those circles intersect, and I'd have to move this green piece over to here. This is my triangle, roughly. You may have done it completely differently. Maybe you did the 6 on this one, on the blue, and you did, if you did that, then your triangle would probably look more like this one right here. So I made sure that I did a couple of different ones. So a 3, 4, 6 triangle. Here are 2 different ones to look at. Now, my question is are they actually different? When you look at these 2 triangles side by side, are they actually different? So they have different colors, but when you look at the actual triangles, let's say this was all, red, 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 or red, red, red. So let me pause my video for a moment. I got somebody else. Okay, now I'm back. Sorry about that. Again, another interruption. This is tougher to do than you think. So if you look at these 2 triangles, assume that they were all the same color, like all purple and all purple. All right, great. So you notice that they both have a 26.5 degree angle, but this one has a 36.4 degree angle where this has 117.1. My question is, what's this angle? Now, the 26.5 degree angle is across from the side that is 3, just like this one. And I bet you if I were to take 117.1 and 26.5 and add those up, 13, 4, 143.6, and subtract that from 180, so let's borrow here. I get 7, 10, 9, 10. I get a 4, I get a 6, and a 3. This angle right here is 36.4 degrees, which is exactly the same as this one. And it's opposite the 4. See how the 36.4 is opposite the 4. So far, these are exactly the same. Oh, and guess what? This is 117.1 opposite the 6. Here's 117.1 opposite the 6. These are the exact same triangle. So another way I could show you that is I could, whoops, sorry about that. Let's go back here. Move that back out of the way. Another way I could show you that they're the same triangle is by tracing this first one. Whoa. That's not going to work too easily, is it? Okay, so if I trace this one, let's see if it's going to let me. Nope. Okay, I'm going to do this the hard way. I'm going to do it by hand, freehand. There we go. All right, if I trace this one as best I can, and I take that shape now, and I move it over here, and I rotate it. Okay, we're getting closer, and then I'm going to take that, and I'm going to reflect it. Let me right-click on that thing. Let's transform that, reflect it in the y-axis. Now you can see that these two triangles are identical. So, the best I can draw it, of course. Now, that means that that everything we're doing here, that if we use 3 sides, we get the same exact triangle. All right, moving over here. Imagine now that 3 possible measures of a side are given. Do you think that everyone will make the same triangle? A, first investigate this question when 3 possible side lengths are given. Use the GeoGebra tool to do this. So we're going to use that tool to make a 1.5, 5, and 4.5 first. I want you to make it. Pause your video, you make it, then I'm going to make it, and we're going to see if we get the exact same triangle. If we do, we will say yes for this one or yes or no. So going back here, hopefully you can see that, I want to do a 1.5, 5, 4.5 triangle. So let's see, 1.5, now, if you're, take a look at your triangle, and look at my triangle. If your triangle can be rotated or flipped over to match my triangle, we're going to call that the same. You might have exactly the same triangle. If your angles are slightly off, that's because there's an error possibility that's going on in here. Like if you miss those dots a little bit, like I did, it could cause a problem. If your line is not exactly 1.5 inches or centimeters, that can cause a problem. So if you had the exact same one as me, we're going to call that one the same. So with these 3 sides, and they ask you to sketch your triangle, we probably don't need to, but these 3 sides, we're going to say side, side, side. This one is yes. Then we're going to do a 4.5, 5, 7. You make your own, I'll make mine. 4.5, 5, and 7. So I'm going to go 4.5, 5, and 7. I want you to try to be different from me. If you can do that, it'd be great. Let's see if we get the same triangle. Whoops, 7. Bring that here. And again, whoop. Don't worry about the angles. If they're really close, that's close enough. But when you rotate the triangle over or flip it over, will you match my triangle? And in this case, again, yes. If we have this side, side, and side, the answer was yes. Now we're going to do 1.5, 4.5, and 7. 1.5, 4.5, and 7. So let's see, 1.5. You try to be different from me. 4.5, and 7. Actually, I'm going to make the red one 7 so I don't run into this. And this one I'll make 1.5. Oh, 1.5. I'm going to move this. Can I move it? No, I can't move it. That's okay. So if I try to do that, let's see. I can't seem to get these sides to match up. I wonder why that is. Here, let's switch this. I'm going to make the blue one 7. Maybe that's the problem. And I'll make the red one 1.5. This ought to fix it, right? And I'm going to try to make a, hey, wait a second. These circles don't cross each other. If the circles don't cross each other, these two sides are never going to make a triangle. I bet you, oh, that's it. These two sides can't make a triangle with 7. They're too short. See how they collapse on each other? So that's not good. This is something called the triangle inequality. So if we use the side, 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 this is not a triangle because 1.5 plus 4.5 is less than 7. In order to make a triangle, the two shorter sides have to add up to greater than the third side. Any two sides of a triangle have to add up to greater than the third side, or it won't be a triangle. So, but so far, the ones that did make triangles, 3 sides were enough to guarantee the same triangle. Problem B, at this point, what do you think must be true about sides of a triangle in order to create at least one triangle? Write down your ideas, then work with your team to test your ideas by selecting at least 3 more sets of side lengths and trying to build them. So what I would say on this one is something like this. To make at least one triangle, the sum of any two sides must be greater than the third side. So if you've got a triangle and this is the long side, I'll call it C, and this is A and B, A plus B has to be greater than C. This is called the triangle inequality. And you'll learn a lot more about it in 8th grade too. Part C, discuss with your team whether knowing any 3 sides of side lengths for a triangle is enough information for everyone to draw exactly the same triangle. Write a summary of your conclusions. So my answer to that one, I would say something like this. If we are given the same 3 sides to draw, we will always get the same triangle. And we could also add in here that this is called side, side, side congruence. Congruent means equal in size and shape, congruence. And you can also call that SSS. That's how I would know it for sure. So if I give you 3 sides, you can make the same triangle as me. Let's add this in here. To see that they are the same, we might need to rotate or flip, rotate and flip the triangles so that they are oriented in the same direction. There. Okay. So A little bit more about that next year too. Oh, my dogs are barking. I wonder who's here. Problem 895. Okay, problem 895, we're going to use the same e-tool this time. And as we're using it, we are going to draw the triangles. They ask and look to see if giving 3 angles is enough information to draw the same triangle. A, one more time, follow the same instructions as you did in 892, including building, sketching, and labeling the figures you make, as well as stating your conclusion for each part. Again, use that GeoGebra tool. So when we make these triangles here, use the same e-tool. Try and get your angles as close as possible. If they're not perfect, it doesn't really matter. We can still get the answer right. So we're going to do a 90-60-30 triangle. So let me refresh this. And let's see here. That's almost 90 degrees. I have found that in order to get the angles a little bit better, if you make the lines longer for a little bit, and then, oh, I almost had it. Let's see here. 90. And maybe I'll make this a little bit longer for a moment. And I wanted a 60 or a 30, doesn't matter. 90, 60, 30. Oh, we're close. Almost had it. There it is. And then a 30 degree, if this is 90 and 60, that's 150. Once I make these triangles match up, and I can do that by making the circles shorter until they meet, but I can't change the other sides. You see how these are stuck? So here's my triangle that's 90, 60, 30, and you might have something different. Check yours, see what you got. In fact, watch this. I'm going to make mine different. Here's a 90, 60, 30. I'm going to make this go bigger. And then I'm going to make this go bigger. And then I'm going to make this go bigger. And here is a new 90, 60, 30. Right about there. Close enough. There's a new one. Still 90, 60, 30. But is it the same as the other one I made? No. So on our paper here, I would put down 90, 60, 30. They ask you to make a sketch of it. So we had a picture that looked like this. And my sides were 6.8 and 3.4. And I don't remember the other side. 6, 8, 3 were 5.9. 5.9. And this was my 90 and my 60 degree angle. And you had something different. So when it asks you this, again, sketching and labeling the figures as you make, as well as stating your conclusion for each part. So this angle, angle, angle is not the same triangle. You had a different one from me probably. Now we're going to do a 90, 45, 45. Test it again. So I'm going to keep that 90, but I'm going to change this angle here to 45, roughly. Oh, it's so close. I hate not having things perfect, you know? So if you're the type who needs to have things perfect, you're more like me probably. They got a 45. And then this one, I'm going to make this a little bit shorter here. Maybe I'll make that one 3.4. I'll make this a little bit longer so they match up nicely. There we go. So that was my problem. You see what you can get and see if yours is exactly the same. If I wanted to show you, I could do this. I could make the blue one go longer, and then I could make the green one go longer, and I could make the red one go longer, and that's a different triangle with a 90, 45, and 45, because it would take two 45s to make 90, plus 90 to make 180. So this is a triangle, but it's different from the first one. So on my paper, Maybe I'll draw the both of those. I had one that looked like this, which was like a 3 and a 3 and something else. I don't remember. And then I had another one, the one we just did, and that one was 4, 4, 5.7. 4, 4, and 5.7. These are different. So angle, 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 not the same. And the last one, 135, 45, and 60. I don't know if you can already see it, but 135-degree angle, 45, and 60. So let's call this one 60. That'll be close enough for right now. And 135, can you see right now that this is not going to form a triangle at all? So this is not going to form a triangle right now. So I would say for problem 3, not a triangle. Maybe I'm going to add one more thing to that. 135 plus 45 plus 60 is greater than 180 degrees. Unhappy face. All right, problem number 95B. At this point, what do you think must be true about the angle measurements in order to create at least one triangle? Write them down. All right, so how many degrees does it take to make a triangle? I hope you're saying that it's 180. So to make a triangle, the angles must add up to 180 degrees. In 8th grade, we will learn that that has a name. That is called the triangle sum theorem. And we'll actually prove it in 8th grade. Problem C, discuss with your team whether or not knowing 3 angles of a triangle is enough information for everyone to draw exactly the same triangle. So I could say right now, without a doubt, because I was able to draw different triangles, knowing 3 angles of a triangle is not enough to draw a unique triangle. The triangles will have the same angles, but may be larger or smaller. Not congruent. So side, side, side works. Angle, angle, angle does not work. Now, before we move on to 896, well, let's do 896, then we'll talk a little more. In problem 894, you found that if you were given 3 lengths to build the sides of a triangle, then if the triangle can be formed, all the angles you could make were the same. Suppose you start with 2 triangles, knowing that their 3 pairs of corresponding sides are the same, as shown below. A, examine the diagram. What do you think the markings indicate, and name the pairs of corresponding sides? So I would say this. How about if we say the markings show which sides match up and are congruent. So to write that down, put that into words, they want to know, name the pairs of corresponding sides. So I could say AC, and then put this little segment over the top to tell me I'm talking about a side, is congruent to, looks like RP. And CB is congruent. CB, that one matches this one, matches PQ. And AB is congruent to RQ. So this side matches this side. What can you say about the two triangles and why? And what can you say about their angles and why? So what I would put here is I would say that by side, 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 since they have three sets of corresponding sides, triangle ABC is congruent, and then parentheses, you want to put the same as, is identical, is, let's do this, is congruent, is identical to triangle, let's see, A to B to C, RQP, period. So my reason for saying they're identical is that they have three sets of sides congruent. If they had three sets of sides congruent, if they're exactly the same size, exactly the same shape, I can also conclude now the angles, I'll say this, the corresponding angles must be congruent because the triangles are congruent. So when we were drawing triangles, drawing three angles matching doesn't tell me they're congruent. Three sides matching does tell me they're congruent. Because they're congruent, then I can go here and I can say, all right, well, that means that this angle and this angle are congruent, this one and this one, and then B is congruent to Q. So once you know they're congruent, then all their parts are congruent. If I had given you a different problem, like for example, let's say I'd given you these two triangles right here and I made them look very much alike, and I said this angle is congruent to that one, and this one is congruent to this one, and that one is congruent to this one, are these congruent? The answer is no, not congruent, because angle, angle, angle doesn't work. We don't know if this triangle here is bigger or smaller than the other one. It can grow and keep the same angles as it grows. So it's an interesting little problem we have, because I can say, okay, well, these have the same angles, but they're definitely not the same triangle. Now, before you do your learning log, there are some other ways to tell if two triangles are congruent. So if you have side angle side matching, so if I gave you two triangles and I said this side and this side are congruent, this angle and this angle are congruent, and this side and this side are congruent, side, angle, side, then these triangles are the same. So side, side, side works, side, angle, side works, angle, angle, side works. So if I say this angle and this angle are congruent, and I say this angle and this angle are congruent, and then I say this side and this side are congruent, these are congruent. Now, the reason why is that if these two angles are congruent to those two, then the third ones are congruent also, because it has to add up to 180, and that would make a side angle, or an angle side angle situation, which is the fourth one. Angle side angle also proves congruence. The only bad one is side side angle. This not congruent. So if you had a side, another side, and an angle that followed them, I could have that same side, this same side, but this angle might be different. And so, or even if that, I could have a side, an angle, side, angle, but because this angle in here has now opened up, these are not congruent. So that's just kind of a little extension. That part doesn't matter as much. What you need to know, the whole thing you need to know is side, side, side is good. Angle, 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 not congruent. For your last trick, I want you to go back and do a learning log for 897. And when you finish that, you can work on this homework 108, 104 to 109. Thanks for listening.